It's two sides of the story. Super excited to be able to measure as close as possible. At the same time, it's a bit confronting to see so little ice in a region where it's normally fully covered with sea ice. For the ocean to go underneath an ice shelf, it has to go through certain processes. It's not that easy, physically speaking, for the ocean to reach underneath these cavities. So for us to really understand how much heat enters the ice shelf, we need to be as close as possible to understand these processes and properties of the ocean.
Minus 1.4 on 4.
Oceanographically speaking, there's two things that have surprised us. One is there's a really strong current right against the ice shelf, and we still don't know what that means for how much ocean heat gets into the ice shelf. And at the same time, we've seen cooler waters than we were expecting at depth, warmer waters within the midst of the water column, which could explain why we're seeing so little sea ice this season. We need to know the bathymetry, and we look for the really deepest parts of the basin. And that is because the warm water that we're tracing is suspected to be the densest water. So that means that we'll occupy the lower part of the water column.
It will be measuring temperature and salinity for us every 5 days, hopefully for the next 2 to 3 years. Then it's going to go all the way to the bottom of the ocean, and then it will float with the currents when it comes back up to give us a phone call. So we'll use this data to understand the water variability, how the properties of the ocean are around the Denman Glacier, and it gives us a bit more of a spatial context to the work that we're doing here on the ship.